Dick Elsy, you're the Chief Executive of the HVM Catapult. Dick, the Catapult, the High Value Manufacturing Catapult, is about just over 18 months old. It's well funded, Technology Strategy Board, I think in total something like £350 million. You can perhaps correct me on
John,
the numbers.
I will correct you on that, mate.
There are 7 centres,
Yep.
nationally distributed, involved in several different specific but also very broad areas of technology access and development in areas like advanced engineering, but also robotic laser welding. I think there's an electron beam welder that's been delivered to the AMRC recently, and additive manufacturing, many other things.
Yep.
Now, could you just explain really for those who've not come across the Catapult, what's its raison d'etre?
Okay, well, it's actually it's a global phenomenon about bringing new technologies to market. I mean, principally, there's fundamental research which takes new concepts from first observed principles up to something which mankind would recognise perhaps as a functional prototype. And then at the other extreme, you've got industry industrialising for large scale its products. So you take something like lithium-ion batteries. You've probably got one on your iPad at the moment. Lithium-ion battery chemistry was developed in Oxford University. You didn't know that.
No.
And interestingly, the first observed principles were there. And it's now, there are billions of lithium-ion batteries all around the world. We're probably no more than a few metres away from anyone at any one point in our life. But those are made out in the Far East. And there's an example of a technology which was developed in the UK, it failed to be grasped and commercialised in the UK. And the Catapult is set up to grab those emerging technologies when they've got to a certain level of readiness or ripeness, if you like, and then, with the help of government-funded resources, take some of the risk out of the scale-up so it's ready for industry to grab. So we're basically kind of incubating promising new technologies through the manufacturing scale-up phase, ready for industry to grab it and implement it. That's what we do.
In your presentation, one of the headline case studies was Rolls-Royce. They developed this advanced disc machining facility with the help of one or two of the Catapult centres, and I think the story is that they probably wouldn't have developed that machining technology as quickly or as affordably without the help of the centre, making it a very attractive proposition to manufacture in the UK. But that's Rolls-Royce, and many people might think, well, surely this is just another great government scheme to really benefit the large companies, the picking winners thing. But that's not the case, is it?
No. We're here to help companies of all sizes with technology scale up. I mean, for sure, the big guys do cast a big positive shadow on the UK. And if you think about it, a company like Rolls-Royce will bring its suppliers along behind it. So if I take a look at Rolls-Royce, there's a long supply chain involved in the Catapult scale-up process. So they've got right down to SMEs involved in that supply chain. But we also get to SMEs outside of that supply chain. I mean, a good example, which we've just talked about today, is Berkeley Plastics, injection moulding. Principally, that's what they do in Birmingham. And we've been helping them break into new markets through the development of new manufacturing technologies. And they've just won some business with Bentley on some new trim parts because we've helped them make a bit of a breakthrough on a new manufacturing process. So we do help a range of size of companies. In fact, I'm beginning to pull together a bunch of case studies of people we've actually helped who want it to be known that we've helped them, and those are available on our website to have a pick through.
And the website's just recently relaunched.
Yeah, we've just launched a completely new website, which is hvmcatapult.com.
Right.
You get the plug in there, and there's all the resources. You can look at all of the technologies we've got in the 7 centres, which range from everything from bio and chemical processing at the Centre for Process Innovation through to final assembly, robotic automation. And I mean, just to give an example of the breadth of the capability, if I take the Centre for Process Innovation, they've got the capability of taking a biological process. So a university has developed in their labs a smart bug in a test tube that can turn a wood pulp into something useful like a organic plastic. Right? Might work at a test tube, but there's a long journey from test tube to being fully industrialised. So at the Centre for Process Innovation, we've got the capability of taking that test tube, scaling it up 250 mil, 1 litre, 10 litres, up to 10,000 litres,
wow.
Nominally 10-tonne feedstock. And that's the bridge, if you like, from test tube, proven it works in a test tube, to 10-tonne feedstock. And that's the point where industry is happy to take it as kind of ready to go. The industry wouldn't dream of grabbing unless it was something really exceptional.
Okay.
You know, they wouldn't normally reach that far back into the research base to grab that test tube and do something with it. So the Catapult is about bridging that gap. And the government money, and I will correct you, we get over 5 years, over 140 million over 5 years. So
that's government funding.
Government funding, just short of 30 million per year for the 7 centres. But in our first 18 months of operation, we've managed to leverage that. And because we've got the capability of doing stuff and making a difference in this space, we've drawn down a whole load of other pockets of funding. So the Advanced Manufacturing Supply Chain Initiative, AMSCI, we've got projects running there. We've already bumping into the sides of the building at the National Composite Centre, which does what it says on the tin. You know, it's all about...
You're doubling the size of it?
We're doubling the size of that. So there's a 28 million investment that's come in for that, and also a national biologics facility, all new, 38 million of government money behind that to be matched by industry. And that's about grabbing another high-value business in the UK, which is smart drugs. So these are drugs that are likely to be bespoke to you as an individual, which demand a completely new manufacturing process. So it's not batch, it's not continuous, it's batch of one with all the disposables and something to go with that. So there's a whole new manufacturing process to be crafted. And the idea is by investing in that, we will embed those industries in the UK. And my firm belief, after 8 or 9 months in the job, is the biggest anchor point for value in manufacturing, the high value in manufacturing in the UK, is knowledge. The Rolls-Royce one you just commented on earlier is a classic example. Rolls-Royce have invested in the UK in a manufacturing facility driven by efficiency improvements from knowledge. It's not about the labour cost. Labour cost is important, but the thing that casts the biggest shadow of all, positive shadow, is the knowledge, the manufacturing process that was developed.
Interesting. And by articulating that knowledge through the Catapult, through the TSB, through industry and academia working more closely, by articulating that, we can generate a more compelling proposition to manufacture in the UK than we perhaps have done hitherto.
Yes, that's exactly, you've got it in one. That's exactly what we're about. And there are plenty of examples. I mean, is this a unique model that the UK's developed? No, it's just in my presentation I showed that there's been some European benchmarking. Germany, with the Fraunhofer Institutes, have been at it not long after the Second World War, actually, so they've been around for a long time. You've got the TNO in the Netherlands, VTT in Finland, all doing the same thing. And so what we're doing is absolutely the right thing. You know, it's a European challenge, not just a UK challenge, but we're perhaps a little bit behind the ball. But there's never a better time to start it.
Also, I guess you're not coming from a standing start, because a lot of these centres were working very intensively on research projects before the Catapult was formed.
That's right.
About 18 months ago. Yeah. So you're sort of making the best of what was
existing. That's right. A key question I asked myself: are we adding, myself and a small core team of 4 of us, are we adding necessary value by bringing this group together? And for sure, the first year results. I mean, we've had 600 projects through the centres, 431 industrial clients. The case studies I've talked about, and we're able now to grasp projects which span not only different technologies, so we can bring together some, say, nano fluids work that we're doing at the Centre for Process Innovation, and we're feeding that across into the Advanced Manufacturing Research Centre in Sheffield. So we're using a new fluid to cool cutting metal.
Wow.
Yeah. So there's interchange between the centres of technologies, and we're also able to move now across sector, because we're bringing the centres together where some may have a stronger automotive focus, aerospace, and we're getting that interchange. And it's getting better each quarter.
Talk about some of the amazing kit that you've invested in at the different centres. We saw some on the presentation there, some giant-sized manufacturing assembly machines. What have you bought recently?
That's just recently been purchased. The really interesting one at the Manufacturing Technology Centre is a 20 kilowatt fibre laser. Now, 20 kilowatts in terms of like domestic heating, doesn't sound a lot, but when it's a laser, that's a big deal. And it's the most powerful industrial laser in Europe on an open source basis. So basically we're giving companies access to that to help weld together in a very precise way with minimum distortion some complicated bits. They may be automotive or aerospace, but it's about developing manufacturing processes using a very powerful, very intense local heat source to avoid distortion and get better right first time. Now you might say, well, a company, why can't they afford to buy one of those themselves? Yeah, but there's the rub, and this is where the Catapult comes in, is even a big company would probably have a challenge to justify several £100,000 worth of fibre laser to develop a process. What happens if it didn't deliver the results? Egg on the face all round. Even more so, of course, for a smaller enterprise, it could bust the business by embracing that. So the whole idea about the Catapult is that with government support, a piece of machinery like that is invested. The academic base that sits behind us at each one of the centres is helping understand how to get the best out of it. We've got the practical skills in the centre that can deploy that learning into a physical industrial environment. And we offer that facility to a whole range of people to use. So suddenly you've got this pooled resource, and the government's stake in that has helped reduce the risk.
And that there are several examples of that type of high-end capital capex where several companies in a group or individually can access a capability which is just simply unaffordable.
Sure. I mean, the National Composite Centre, we're investing. We've just put the orders in for a big resin transfer press. So this is about moving carbon fibre to a new production scale in timing terms, because traditionally carbon composites are done in an autoclave in a vacuum oven. Yeah. So you get locked in the oven for several hours, and that, of course, that's an impediment to high volume applications.
So anti-lean, really, isn't it?
Yeah. So resin transfer press is a big short travel press to squeeze fibres together and inject resin into them. So it's the kind of high volume process, and we've invested in a very large press which is going to go into the National Composite Centre, but it's going to be used by the aerospace guys because they're developing the technologies for the next generation of aircraft. And the size of components that they're working on are remarkably similar to the kind of floor pan of a car. And the car industry in the UK, which is doing really well at the moment, the premium car industry in particular, needs to keep its competitive edge in the face of CO2, so it needs to take weight out of its products. We've already seen the new wave of aluminium coming through. Well, they're now beginning to look at composite technology as well. So it's very interesting. You've got demand from automotive and from aerospace sharing the same piece of kit, and probably neither of them could have taken the punt and afforded the machine.
Sure, that's interesting.
Yeah,
so we're looking at OEM car manufacturers looking at composite technologies to manufacture body parts.
Big bits. Not just little.
Sure, and that's coming on. That's happening right now.
The machine's been ordered. The demand's there, and we've got to match that demand, and that's why principally the National Composite Centre has been doubled in size to match that demand.
Sure.
So the fascinating thing for me is the demand is out there. This is, sure, it has to be sold to make people understand what's out there and what can be accessed, but the industry pull for what we're doing is quite extraordinary.
It's greater, because this is an interesting point. The demand is very high, but clearly, as an organisation like anyone, you'll have challenges. But at the moment, it doesn't seem that a significant challenge for you is to attract more customers, that they're coming naturally.
Yes, well, each of the 7 centres has its own business development people who are naturally predisposed to grow their business. I'm doing a bit of business development for the whole core. I'm taking on the responsibility of pulling the team together to look at accessing European funds, because we've got Horizon 2020, the new wave of European funds, so we're getting connected there. But my biggest worry at the moment is our ability to expand to meet demand. We're bumping in. I told you about the National Composite Centre, Manufacturing Technology Centre in Coventry. with the demand, it's at capacity, and we've got to find ways of expanding that facility, and we haven't got a clear route to do that at the moment, but we're working hard on that.
Actually, quite a nice problem to have, really. But
it is a kind of frustrating. And I was talking to Lord Browers about how things were going. I said on a good day, I'm 80% inspired and 20% frustrated. He said, "What's the frustration?" I said, "Well, it's this ability to expand quick enough, which will need more government investment. And I don't want to be sitting on the sidelines sort of whinging that there's not enough money. I mean, the fact is there isn't. And my objective is to really show ministers who've put the commitment behind us what we can do. And I'm trusting in logic and common sense to let stuff flow through from there."
More investment from the government and the science community
Well, principally, this is about extra money. This is not about robbing the research base.
Sure.
Because we shouldn't denude that at all.
The research councils.
We shouldn't, because we've got some of the best research in the world from the UK, and it would be the wrong thing to do to rob that to fund the Catapult. In fact, it would lead to an inappropriate competition for resources between the universities and the very thing we need to grab that research and scale it up. So this is about new money. But the scale of the new money in the overall scale of the challenge isn't that great. And I'm just hoping that logic and common sense see through. Having said that, government's been very supportive of some of its strategic industries it views as strategic. You heard Lord Browers, it was Michael Fallon that announced it's already been announced, but the £1 billion for aerospace. So it won't surprise you that in that challenge for aerospace to develop the next generation of aircraft and engines and landing gear, all the stuff that we manufacture in the UK, they've got £1 billion of government support to do that, which they're going to match. It's no surprise that some of the execution of that manufacturing will be done through the catapults. Yeah. It's interesting, when I first joined the job, having spent 30 years in industry, almost feeling, I wonder if this could be self-funding. That's interesting. And I've now, after 8 months, I've got completely the opposite view. Completely opposite view. And the reason for that is that if it became self-funding, it infers that industry's funding itself, it will naturally gravitate industry towards more vanilla-flavoured technologies that are safer, less risk. And so all that stuff I've just talked to you about, would industry go and invest in the fibre laser to have a go at it? Not sure. So it's about sharing in that risk is really crucial. And the other really important thing is if there was a move to make it self-funding, it would make the centres be much more retentive with intellectual property, because it would have a value to sustain their business. We're completely open with it at the moment. We're pushing out all this common learning that we do around the 7 centres is being pushed out to industry to add the value. So I've got completely the opposite view. And I think the government funding is so crucial to that risk reduction and that openness, which I think has acted as a real catalyst for businesses who see the centres as a neutral environment to collaborate. I mean, I said in my pitch that we've got two fierce competitors, Airbus and Boeing. Airbus have just joined the Advanced Manufacturing Research Centre in Sheffield. Yeah. And you think, well, how does that work? Well, Boeing and Airbus would say we compete on aircraft design, but don't necessarily compete on new ways of cutting metal. And that's what they're sort of things that they're doing
But
together.
That type of collaboration in an odd way wouldn't be possible without the government.
No, because it does provide that neutrality. And companies like to see some real skin in the game, and it's not an awful lot of skin, really.
Okay. Well said.
In the overall scale.
Well, Dick Elsy, CEO of the High Value Manufacturing Catapult, thank you very much.
It's been a real pleasure.